On this day, we are going to spend some time identifying congruent figures and then talk also about what's called the corresponding parts. So key first is, can we identify if two things are congruent, and also use the parts that are congruent. So what does congruence mean? Congruence mean same shape and same size. And next, what about corresponding? It means same relative position. Next thing, what are congruent figures? Well, that's actually pretty much the same as over there, because we're going to unpack that in a minute. So it's pretty much figures that are the same shape and size. So we're not going to spend too much time on that. But what is a congruence statement? A congruent statement will look something like this. Triangle MAT is congruent to triangle PLZ. Or it doesn't even have to be a triangle. It could be some other shape. For example, it could be a quadrilateral triangle, or excuse me, ABC. And that's not a D. Let me fix that. Is congruent to EFGH. So it doesn't matter what shape it is. We would say it like this. And we would just say, in this case, we say triangles. Down here, after a while, we don't need to put the symbol in front, just because it would take almost too long to draw an octagon and an octagon there. So remember that whenever we come across this right here, where I have a triangle is congruent to a triangle, this is the congruence statement. This is a congruence statement. So oftentimes that will say, so give a congruence statement. So you have to say that such and such a triangle is congruent to another one. Okay. When you do sketches of triangles, number one, we don't know what kind of triangle this is here. All we know is that it's a triangle. We don't know if it's a right triangle, isosceles, or anything. And I know oftentimes, and please don't draw right now, is oftentimes when we draw a triangle, people just like to draw this. Because when you were 3 years old and you had a little puzzle and it said, find the triangle, it was almost always an equilateral triangle. Okay? So what we want to do, though, is avoid a special triangle. Equilateral is a very special triangle. So whenever we draw a triangle, if we don't know what kind of triangle it is, try to draw a generic triangle. So for example here, this triangle has nothing very special about it. There aren't any right angles. There's nothing necessarily congruent. It's not isosceles. So this is just a generic triangle. So when you do draw a triangle, please try to draw it not specific. Something like this. So we're told that triangle ABC is congruent to triangle DFE. So how would I draw that? When I draw the second triangle, I'm going to try to make it as exactly the same as the other one. Now, I'm also orienting it the same, but remember, it doesn't have to be oriented that way. It could be upside down. It could be this way. So it could be almost any way. But just for ease right now, I'm just going to have it oriented the same way. Now notice, so since I put A here in this angle here, I'm going to put the D in the same relative position because it corresponds. Next, I put B up, so I'm going to put the F up. Wait a tick. Why did I put the F up? Well, notice the order up here. See the order, A, B, C, and the order here, D, F, E. So the A corresponds to the D, the B corresponds to the F, and lastly, the C corresponds to the E. So the order in which it is written in your congruence statement, the order up there, is extremely important. In fact, it's more important than the diagram itself. This order up here is more important than the diagram itself. So what can we extract from this? It turns out that not only do we have corresponding angles and corresponding sides, it turns out that they're corresponding, but they are also congruent. And the same thing applies here. By the way, the corresponding angles, that's the part that tells me we have the same shape. It's the angles that determine shapeness. So what do you think the sides determine? Same what? So here, same shape, same size. It's the congruent sides that determine size, and it's the congruent angles that determine the shape. Okay, so when I'm talking about my corresponding angles, notice my first letter on the first triangle is A, so I'm going to say that's congruent to the first letter in the second triangle, D. That's from Napoleon Dynamite. Napoleon, don't be jealous that I've been chatting online with babes all day. Besides, we both know I'm trained to become a cage fighter. A cage fighter? You have the worst reflexes of all times. Come down here and see what happens if you try and hit me. All right, let's take a gander here. Now here's the next part, and I'm going to delete some of this over here, is when we're talking about the sides, notice that AB comes first. DF comes first. So there is a pair of sides. So corresponding / congruent also, AB is going to be congruent to DF. Notice I'm not concerned about alphabetical order. I'm concerned about the order in the congruence statement. All right, next, I could say that BC is congruent to the FE. So there's our BC is congruent to FE. That A and C and D and E are congruent. So over here, AC is congruent to DE. And notice I'm keeping the exact same order that's over established just in this small statement. Now let me go ahead and mark the diagram so that we know. We know that AB is congruent to DF, BC is congruent to FE, and I'm going to use triple down there for the last congruence. In terms of triangles, I know that A is congruent to D, so I'm going to put a double mark on the B and F, and a triple mark or a triple arc on the last. It does not matter which one of these gets the single, the double, and the triple. The important part is that the AC has a triple, so must the DE. They must match up. BC corresponds to the FE, therefore congruent. So I make sure they have the same number, either 1 or 2. So as we are working on this, when we are told this one thing, it splits up into 6 things. We know 3 things about angles, and we know 3 things about sides. So this one itty bitty piece of information explodes into 6 pieces of information. All right, so down here, as we are looking at, and let's pay attention real quick to note the difference, notice on number 4, it gives a congruent symbol. Because of that, I know my answer right here is going to be another angle. However, note on number 6, that's not a congruence. That is an equal sign. So my answer there is going to be a number. So let's see how that works out. Over here, since M comes first, try that again, since I'm talking about L there. Since L comes first, no, I'm talking about L here. Here I'm talking about L. And L over here is the 3rd letter. So to what does it correspond over here? The 3rd letter is T. So over when I look at my diagram, L, so I can even mark it congruent to T. And we say, wait a minute, I don't know what that is yet. Well, what are the other congruences? M is congruent to J. And so that means this one here has to be 85 degrees. Oh, so I actually have enough information to find out what L is. Now, it doesn't ask me to find out how big L is yet. Notice right now it just asks me to find out to what is it congruent. So I don't even need to look at the diagram for that. It's the last letter. Now, number 6 gives me an equal sign. So I'm supposed to put a number here. How many degrees is the measure of angle M. And we already just found that right here. Since J corresponds to M, those are congruent, so I just brought the 85 over. So that means the measure of angle M is 85 degrees. And I'm going to delete this number. That was just a hint. All right, just to show you, this one right here says equals, so you're going to write a number over here. How long is ML? However, this is a congruence, so you're going to mark a segment. This is a congruent, so you need to mark a triangle here. Take a few moments to complete those. We're going to use this property tons, and later we're going to officially call it something else, but we're going to use the properties of congruence to solve for more missing lengths. So once we identify the corresponding angles and the corresponding sides, we can now state them as congruent. That individual pieces are also congruent. This has a name, and it's a beautiful name, C to the P to the C to the T to the C.
What?
I know. C to the P to the C to the T to the C.
C to the P.
C, P, C, T, C.
I did too.
And you don't need to know that yet. We will define CPCTC later, but it means this. Corresponding parts of congruent triangles are congruent. C to the P to the C to the T to the C. So let's apply. When we have a congruence statement here, so we're told that triangle CBA is congruent to triangle HKI. Clearly, I see that C and H, those angles are congruent. So C and H are congruent. In fact, specifically both 90 degrees. B and K are congruent. So this one here matches up with this one there. And lastly, I know that my A corresponds to the I, so that this one here matches with this one here. So if I were to set things equal to each other, notice here, these two are congruent. So I can say 2x plus 18 is equal to 52. So we'll finish this puppy up. And when we divide, we end up with 17. Remember to box or circle the answer when you commit to it. Now we're not done because it does ask us to find y. Now notice when I'm looking at y here, I'm not going to use the two triangles. I'm just going to use the one triangle. Class, what do the three angles of a triangle add up to? 180. There we go. So I can now write this and say this. 3y plus 11, that's the measure of angle k, plus the right angle, which is 90, plus the 52, that's at the top there, and all those sum to 180. Now I'm going to combine my like terms, and then subtract to get 27. So now divide by 3, and my answer is y equals 9. Notice that I can check real quick. The reason I know that what this should be is I can just plug a 9 here to get 27 and add that to 11 to get 38. And 38 plus 52 is 90, plus 90 is 180. So we know that it definitely works up that way.